All right, guys and gals, we're back with functions, and we're looking at y-intercepts today, but we're also going to add a new layer to that, this idea that we're going to call initial values. So just hold on to that idea for a moment, and we're going to come back to it. We're going to start with y-intercepts, and today we're going to look at how do we find those beginning points in equations. So let's review real quick. When we look at a linear function, we said that this was sort of the format that we were going to go with. The name for this format is slope intercept form. And the reason that we gave it that name is that the m, remember, represents the slope, and that the x represents an input, the y represents output, and then we said this b, this number that was tacked onto the end, was something that we weren't quite ready yet. Well, we're ready now. B is the y-intercept. In other words, if I were to graph an equation, let's say this first one, this y equals 6x plus 4, then I know based on the slope of 6 that it's going to be a pretty steep line, and I know from the 4 that it's going to cross the y-axis 1, 2, 3, say 4 up. So this line is going to look something like that. It's got a 6 for a slope, so it's going to be pretty steep, and it's got 4 for a y-intercept, so it's going to cross 4 spots up on the y-axis. So here's how we can find y-intercepts, this crossing point, just by looking at the equation. The first thing you want to know is that you want to have y all by itself. In other words, we want our equation looking like this, where we've got it just y equals a number. In this case, y equals 6x plus 4. We don't want it anything else. Nothing else with the y, just y equals, all right? And then what we're going to do is we're going to look for the constant. In other words, the number that is by itself. So here is my constant in this case, my 4. So if I were asked for the y-intercept of this particular situation, I would say it's at the point 0, 4. Remember, we said all y-intercepts look like this. We said they start at 0 and then comma, and then some number wherever it happens to cross. So in this case, we're going to cross at 4. So 0, 4 is where we need to end up. All right, let's look at another example. Take a look. We've got y equals m, so 5 over 7 is our slope, so 5, 7, x. And notice it's usually written out as plus b. Well, okay, let's change that out. So we'll change it to add the opposite. So remember, add a line, change the sign. So in this case, we're adding a negative 6. So this time my y-intercept would be at 0, negative 6. So if I were to graph this particular line, it's going to cross the y-axis somewhere down here in the negative area. Or notice this one was positive, so it crossed up top. All right, let's try another one. All right, so we've got y equals m. So in this case, our slope is negative 12. There's our x, plus b. Notice there's no constant that's being shown as added on. If we have a case like this where there's nothing added or subtracted, we assume that we're adding 0. All right, notice originally there was nothing there, just y equals a negative 12x plus nothing. Well, we can go ahead and write that plus nothing in to give us an indication of where that y-intercept would be. So if I were to graph this particular line, so let's do that real quick. We'll do a rough graph. If I were to graph this one with a negative 12 slope, that's really steep but heading down. And if we're adding 0, that means it's going to cross right here where y is 0. So it would look something, goodness, like this. Really, really steep heading down right through the origin. So our y-intercept in this case would be 0, 0. And that's okay. Sometimes lines go through there, and that's fine. All right, let's look at this next one. Y equals, notice no mx. Remember, we said if there's no mx, we could rewrite it as y equals 0x. And in this case, subtract 4. So let's rewrite that. We'll write it as adding a negative 4. So we have a 0 slope, which we don't care about. Our y-intercept in this case is negative 4. So we'd write it as 0, negative 4. And if we were to graph that, it would look something like this. So here's our xy axis. Notice it's got a 0 slope, so it's going to be a nice flat line, and at negative 4. So maybe 1, 2, 3, 4 down. So it would look something like that. A nice horizontal line crossing right here at the point 0, negative 4. All right, so there it is. All right, let's look at this next one. Notice we don't have y equals. So let's go back up to the top. Here we said you want it so that the y is by itself. In other words, I don't want to know 2x minus 9y. We don't want all that. We just want this to be y equals. So let me show you. I've got plenty of space over here. Let me show you how we're going to rewrite this 2x subtract 9y equals 8. Let me show you how you're going to take that and rewrite it so that way it's just y equals. All right, first thing I'm going to do is make this addition. So adding a negative 9. So that's good. Y wants to be by itself, so I got to get rid of this x first. So what I'm going to do is I'm going to subtract 2x from both sides. All right, well, 2x subtract 2x zeroes out, so that leaves just negative 9y behind. Don't forget the negative. Over here, I can't actually subtract 2x and 8 because they're not like terms. So I'm just going to write it as a negative 2x added to a positive 8, just to show that I've got that work to do, but can't do it yet until I know what x is. All right, last step. I've got to get rid of this negative 9. It's being multiplied by y, so I'm going to divide everything by the negative 9 to undo that multiplication. All right, so here we go. So y, because 9 over 9 is 1, so y equals, and notice that's what I want. I want the y by itself. So here we go. We've got y by itself. So y equals, a negative divided by negative is positive, so positive 2/9. And again, there's no point in working that out. 2/9 is a repeating decimal, plus fractions are perfectly good for a slope. So this is our slope. We're going to leave it as is. So just 2/9. Added on. And then over here, we've got 8 over negative 9. I'm going to rewrite that as negative 8 over 9 instead of 8 over negative 9. The negative could go in either spot. I just think it looks cleaner here. So notice we've got the y all by itself. We're looking for the constant. In other words, the number that's all by itself. So y isn't it. The 2 over 9 is not it. That's our slope. Here is our y-intercept. So it's going to occur at the point 0, comma, negative 8/9. So almost at negative 1, not quite. So in this case, we could write our answer as 0, comma, negative 8/9. And again, I'm not actually going to try and work that out. If you take 8 and divide it by 9, you get 0.8 repeating, and that's a terrible number. So we'll keep it as a fraction, and that happens from time to time. So again, we're going to take the original and rewrite it so that it's in our slope-intercept form. All right, let's try this one more time. This go around, I've got a negative 3x subtract 4y equals 27, and I want to rewrite that so that when I'm done, it's just y equals. All right. So the first thing I'm going to do is change this out, add a line, change a sign. It's just easier to read. I'm going to go ahead and add 3x to both sides. So add 3x here, we'll add 3x here. And remember, negative 3 plus 3 zeros out, so that gives us negative 4y. On the other side, I can't add 3x to 27 specifically, right? We can't actually work through that. So 3x added to 27, we'll just have to write it like that. Got to get rid of that 4. It's a negative 4 being multiplied by y, so we'll divide. So let's divide everything by the negative 4. Right, let's see what we get. In this case, 4 over 4 is 1, so there's that 1y. We're looking good. 3 over 4x, in this case, a negative 3 over 4, so we can rewrite that, negative 3 over 4x. So there's our slope, and we don't care about that. Let's keep going. Add it on. Our intercept. In this case, we would have a negative 27 over 4. Now, when it comes to slopes, if this were our slope, then we would just leave it as negative 27 over 4. We're okay with impropers. But when it comes to y-intercepts, we don't really want to leave it that way. So take a look. Your calculator can help you out. One way we can do it is just take negative 27, divide it by 4, and we end up with negative 6 and 75/100ths. So we could say our y-intercept in this case is 0, comma, negative 6.75, and that would be perfectly acceptable. One way to do it. Another way to get our answer is to keep it as a fraction, right? Now notice this is improper. We don't want it like that, so we'll need a mixed number. So the other way to do it in your calculator is to type just 27, because we know it's negative. We hit our ABC button and 4, hit enter. And remember, this was a negative number, so negative 6 3/4. So that's another way that we could get the same answer and just write it as a fraction. So again, it's perfectly acceptable to write y-intercepts as mixed numbers, though we tend not to do that with our slopes. So if this were our slope, we would just leave it as negative 27 over 4. Since we're finding y-intercepts, it's perfectly acceptable to write it either as a decimal or as a mixed number. We're good either way. All right, so cool. So that's how we deal with equations. It's not too big of an issue. Let's talk about our favorites. Let's talk about word problems. All right. Here's the change. In graphs or in equations or in tables, we talk about y-intercepts. When we're talking about a context, right, like we've talked about before, a real-world situation, then we don't use the term y-intercept so much. Instead, we call it the initial, there it is, knew that looked weird, initial value. Initial meaning starting. So our starting value. In other words, where does our situation begin? Now, in some situations, when you are looking at a word problem, they're going to come right out and tell you. So when we're finding those initial values, one way to do it is just to look for something that's called an initial fee, one-time payment, a starting point, things like that. And that's going to clue you in and let you know, well, there it is, and we don't have to worry about it. If you aren't, all right, well, then you'll probably need a slope. You'll need to pick a point and use our formula that we've done before to find that y-intercept. So let's go through a few examples. All right, this first one. It says the Lamar taxi service will charge you $1.50 per mile and a flat fee of $3. What is the initial value? Well, again, anytime you have an initial fee, a starting fee, a one-time payment, that's going to be your y-intercept. So in this case, as soon as you set foot into the taxi, you already owe $3, even though they haven't taken you anywhere. So if we're going to write this number as just a y-intercept, we could write it as 0, 3. All right, and that's one way of doing it. The other way for initial value is to talk about what does that mean. So in this case, it means that we have a fee of $3 before we ride. In other words, before that taxi is even taken out of gear and gone into drive, you're going to owe $3 right up front. All right, let's try another one. So Moss Brothers Plumbers charge $100 for house calls and then $35 per hour for labor. All right, what's the initial value? Well, notice $35 per hour, that's a rate. And we're not looking for rates, we're looking for y-intercepts, initial values. And it's right here. They're going to charge you $100 for that house call up front before any work is done. So if we're going to write it as a y-intercept like we did here, we would write it as 0, 100. As an initial value, we would say we owe $100 before work begins. And anytime you have work done on your house, whether it be plumbing, electrical work, that kind of thing, a lot of times they will charge you a house call fee. Maybe it's $100, maybe it's $150, whatever, and then they'll charge you so much for labor after that. So this is your initial amount. So at minute 0 or hour 0, what do you owe? Well, you owe $100 just for them to park the truck in your driveway. All right, so there it is. Let's try another one. Mr. Morse is flying to Chicago. He's making his approach for his landing, so it sounds like he's the pilot. Currently, the plane is at 32,000 feet. He will descend at a rate of 2,000 feet per minute. What is the initial value? So again, I see this 2,000 feet per minute, and that's a rate. So that tells me if he's in his airplane, I'm not going to draw a decent airplane. That's horrible. Try and make it a little better. There we go. So there's the airplane. All right, and it's descending, right? It's heading downward at 2,000 feet per minute. So that's the rate of change. The question is, what's the starting point? And at this case, it's the 32,000 feet. The fact that he's at 32,000 feet to begin with and will eventually end at foot number 0, 0 feet above the ground, this is where he's starting and this is where he will end. So our initial value in this case, we could write it as 0, 32,000. And if we're going to talk about the meanings, this is our y-intercept. If we're going to talk about the meaning of it, we would say that Mr. Morse is 32,000 feet above the ground before he starts to land. And that tells me where he starts at, right? He's beginning at that 32,000 feet mark before he makes that approach into, say, O'Hare Airport or Midway, wherever he's landed in Chicago. All right. So let's try another one. It says Mr. Hunsaker is planning for his summer road trip. All right. His rental car agency will charge him $230 for 2 days. If he needs the car for 5 days, the cost is $370. What is the initial value? Uh-oh. Notice, this is one of those cases where we don't have an initial fee or one-time payment or starting point that was told to us up front. Instead, we're going to have to go with the second method. We need to find the slope, pick a point, and then use y equals mx plus b to solve for that. So let's do it. So first thing we need to do is find our slope. And in this case, we've got 2 points to pick from. We know that for 2 days, it's going to cost $230. Because remember, time is almost always an x value, so that's why it's in the x position. And then if he needs the car for 5 days, it's going to cost him $370. All right, cool. So first thing we need to do is find our slope. So let's do that. So I'm going to let this be 0.1, let this be 0.2, and we're off to the races. $370 subtract $230 over 5 subtract 2, because again, x and 2 and then x1. So let's see what we get here. So if I take the 370 and then subtract that from, what was that, 230, we get 140? Yeah, $140. And then for 5 subtract 2, that's of course 3. And now it's a matter of doing a little bit of math. Because notice, I don't want to leave this as $140 over 3, what did this represent? Days, not minutes, Lord Almighty, that'd be expensive. Days, simply because that doesn't make a lot of sense. Most of the time, we don't want to look at rentals in that regard. So if I divide by 3, we're going to get roughly, because we'll have to round it here, roughly $46.67 for every 1 day. Whew. So that's our rate. Cool. So there it is. So now that I've got that information, I need to pick one of these points. So I'm going to pick this one right here just because the numbers are small. And we're going to take that and we're going to plug it into our equation, y equals mx plus b. And remember, the x and the y represent the x and the y from the coordinate that we've selected. So remember, 2 is our x, 230 is our y. So let's plug that in. So 230 equals our slope. We could use 46.67. That's a rounded number. We could also use 140 over 3. I'm going to go with 140 over 3 just because I think that's going to be a little bit easier to work with. I'll show you here. Multiplied by x, so in this case 2, and then plus b. So what we're going to do is we're going to solve this equation for b, and that's going to give us our initial value. In other words, what would it cost Mr. Hunsaker in this case? So I'm going to take 140. I'm going to multiply it by 2, divide that by 3, and we're going to get, let's see, 230 is equal to, again, a rounded number here, $93.33. All right. And again, that's why I'm going to round it there, because it's a dollar amount. We're going to take that and subtract it from our 230. So in this case, it's going to be, we'll call it 136, negative, 100, oh, excuse me, not negative, positive. I'm reading that wrong. 136.67 is equal to B. Yeah, I read that wrong. So cool, our initial value is $136.67 for his rental car. So one way to write it is as a y-intercept. So we could write it as 0, 136.67, and that's fine if we were going to graph it. If we're going to talk about it in context, though, we could say that Mr. Hunsaker will pay an initial fee of $136.67 for his car. So in other words, before he ever hits the road, before any miles are taken, he's going to owe the rental car agency $136.67 just for the joy of renting the car. All right, cool. Doesn't sound terrible. Doesn't sound great, but doesn't sound terrible. All right, so let's try one more. Miss Keppen, she's traveling through Greece, so she's on a holiday as well and needs to call home. Who doesn't? It says a 5-minute overseas call will cost her $5.91, and a 10-minute call will cost her $10.86. So $5.91 and then $10.86. What is the initial value? So in other words, what's it going to cost her up front just to make the call? Regardless of how long it is, what's the initial fee that she's going to be spent? So let's work it out. We're going to do it the same way we did here. So the first thing we need is our points. So 5 minutes is 591. So let's write that down. 5 minutes. Minutes is time, almost always x, to 591. And then a 10-minute call will be $10. Nope, $10, not $18. $10.86. All right. So let's find slope first. So I'm going to take 10. Oh, I keep doing that. 1086. And we'll subtract 591. And then we'll take 10 and subtract 5. Cool. So if I take 1086 and subtract 591, make sure we write this correctly. Oh, goodness. 91. Here we go. Is $4.95 over 5. So we can go ahead and divide that out. So it looks like it's going to be about 99 cents per 1 minute. Kind of expensive. Almost $1 a minute to call. All right, so now that we know that, we can take it and plug it in, just like we did here, y equals mx plus b. And I'm going to pick this first point for no other reason than the numbers are small. So y equals mx plus b. The y in this case is $5.91. The m in this case is the 99 cents per minute, multiplied by our x, in this case 5, plus b. Cool. Well, if I take 5 and multiply it by 99, we get, well, maybe my calculator's giving me something all the way in the millions. I'm not sure what that's about. Yes, that 495 back. So 591 equals 495 plus b. Looks good. We're going to subtract 495 from both sides, and that will give me what we want. So 591, we'll subtract our 495, and we get 96 cents. Cool. So one way to describe this is as a y-intercept. So we can say 0, 0.96, so almost at 1, so almost 0, 1 if we were to write it as a coordinate. If we were going to talk about it in context, we would say that Miss Keppen will pay at least, what did we say, 96? Yeah, 96 cents for her call, right? And that's that initial value, or initial fee rather, up front that she'll have to pay, plus whatever it is per minute. So that's what we'll be looking at today. Still looking for y-intercepts, but if we have context, then we'll know it as initial value. Again, all y-intercepts are 0, a number, and then all initial values, we're going to try as best we can to give them context. What do they mean in the real world? So this 0.96 is 96 cents for the phone call, or 136.67 is $136.67 for that initial fee, for example. If you have questions, make sure you bring them with you. And again, make certain you're taking good notes, folks. Good notes are going to save you in the end. Have a good day.